So some takeaways for accumulation and absolute maximums and minimums. I am positive you will be asked this somewhere on your AP test, that the derivative of any quantity will always tell you if that quantity is increasing or decreasing. So they'll ask you if something is increasing or decreasing, you'll need to show that the derivative of that quantity is either greater than zero, increasing, or less than zero, decreasing. That's one takeaway. Another takeaway is that the integral will always sum up or accumulate the rate into the quantity without the time. An example, if you were looking for gallons, you would need the integral of gallons per minute. Similarly, if you wanted distance or position, you would want the integral of velocity. If you wanted penguins, you would need the integral of penguins per year. That's a key takeaway. And then with the absolute max and min problems, you'll probably be asked one. And it'll be on any interval from 0 to 5 or 1 to 3 or some kind of interval from A to B. First of all, the absolute max and min can only occur at the following: x equals a and x equals b. Another way to say is the endpoints. And also x equals an interior critical point where the derivative is equal to 0 or undefined. You'll need to show this. Show that your rate, which is equal to the derivative, is equaling 0. Whatever those times are, if there's one or more, that's what you'll check as an interior critical point. Here would be an example. A would be an endpoint and B would be an endpoint. So my value that I was trying to maximize or minimize would be the initial amount plus the integral of the rate from A to A. Well, that means this is all going to be 0, and this 30,000 would really just represent the initial amount. Could be penguins, could be gallons, could be anything. Let's say we had 2 interior critical points, 1 and 2. Well, we'd also take our initial value and we'd have an integral from the starting point to that first interior critical point. That might give us 2850, 28,500. We might have a second interior critical point. So we'd have that same initial value. Of course, that would be 30,000 in our case. Plus the integral from A to critical point 2 this time of RT dt. Let's say we got 31,000. And then our integral at the endpoint B, let's say it was 27,250. Well, that means the absolute max would equal 31,000. This time that happened at an interior critical point. Our absolute min would be equal to 27,250, and that this time was an endpoint. Couple of key things to be careful of. You may not always be given a rate function. I've seen questions on the AP test where you're given the function for gallons or position or penguins, etc. So you're given the quantity that's not the rate, but is the desired quantity. If you were looking to find the maximum or minimum, this time you'd have to take a derivative. The derivative wouldn't be given to you like it was in our example problem. You'd take that derivative, set it equal to 0, and that's how you'd find your critical points. Then you wouldn't take an integral because you were given the function for gallons or position or penguins. So you would find your maximum value by just plugging in your critical points into the original function. So every one of these is different, and as you look in the OneNote, you'll find lots of different examples. Try as many as you can till you're consistently getting them right. Then you know you're ready for the AP test in this topic.